Let me talk to you today about some work we do on the IoT security in my lab. And in particular, I will try to draw some, let's say, some guidelines or vision about how we could improve the security of IoT. In particular, because in our case, or in many cases, the IoT device that you have are not exactly, even if you are the owner of the device, you don't exactly have the control on the devices in many cases, because you buy devices from local store for your home, but even for company, and then the devices are not actually managed by yourself. So what can we do in that case? It's basically the topic of my talk. So first of all, I want just to make sure that I think we are all aware of the problem of security with IoT. But I want to show you some measurement we did in our lab. Okay, so let me introduce very briefly one platform. This is not dedicated to the IoT, but it's a platform that allows us to observe attacks globally in the internet and to do some, let's say, security monitoring over a target system. So most of the time, when you want to do some security like monitoring, detection, prediction, you just look at your system you want to protect. And of course, then you add some public databases that you can use, particularly Blacklist. I think this is well known. You use Blacklist, for example, to filter out the traffic. There are many different kinds of stuff you can use, and we even go further. For example, you can look at social networking. You have a lot of important information that you can take from there in order to be able to predict attacks. And then, in our case, we go a bit further because we have dedicated security probes that allows us to monitor the security at the internet scale, let's say. We have honeypots that try to trap attackers. We have also darknet. I will talk you a bit more about that afterwards. And some active probing techniques. We have a lot of components, and I will not detail all of them, of course. We can do some DNS monitoring, filtering. We can detect we have also some work on botnet detection, but I will not enter into the detail of this one. One important thing is, I will show you in our honeypot, for example. Here is a SSH honeypot. We just collect, we are not only collecting that, but what I show is just the login and passwords that are tried by the attackers. Of course, I think you have already seen all this kind of list of top password use and top, let's say, naive password use, like 1, 2, 3, 4, admin, and things like that. Which is interesting here is that for many of them, you see, okay, it's probably naive password, and if attacker look for that password, it's because users still use it. But for some of them, it's not only naive password in the sense that it's very generic password, but it's also a very specific password to certain devices. I will not tell which one, but I think you will be able then to find it. And of course, we find exactly the same default password on these devices when we got in our lab, so we just buy it, take it out of the box, and we finally find this password. So basically, you have default passwords enabled on the smart plug, meaning that you plug this smart plug into your network. If you're a normal user, then you play with it, on, off, okay, it works, perfect. But of course, if you are, in our case, researcher, somebody who wants to dig a bit more into the security of the thing, you will do some assessment. And you will see that actually it has many services active. And most of the service, you don't know why you need that. Here, the goal is just to do on-off remotely. You don't need, for example, DNS server for that. Okay, you probably maybe don't need SSH server. And many of that service are active. And the worst is that many of software behind the service are outdated software with known vulnerability for a long time. So meaning you put that into your home, you plug it, then your device is exposed to any attack. And surprisingly, having a DNS resolver can be used to actually act as an amplifier for denial of service attacks. So yeah, there is probably one problem. So this is something that we saw in April 2016, and I think this one, Mirai botnet a few months later. Okay, and actually, Mirai botnet was a very simple software because it does not have specific new attack, zero-day attack. He just tried to enter into IoT system. We say IP camera, but it was not only cameras, it was more IoT device in general. And what it does, it just try to enter into the system, it just try a list of 61 passwords, 61 login passwords, which is very small. It can be tested in a second. And of course, we found again the same on the previous plugs and the one we saw in our darknet. So darknet is just a way to collect data at large scale. So yeah, surprising for doing this very attacks that basically have very big impact over internet with partial blackout. You don't need very good skills attackers. Anyone can do it. No particular expert, no real expert, no zero-day attack. So what is a darknet? So it's not the darknet in the sense of dark web. It's a darknet in the sense of network telescope. Basically, we have a big subnetwork at the lab which is dedicated to silently collect traffic over the internet. There is no active host. There is no service running via these IP addresses. And so normally we should not see any traffic incoming into these IP addresses. Of course, we see a lot of traffic. It's what we call internet background radiation. You can find a lot of studies in the literature about that. You're able to see what are the denial of service attacks, for example, what are the services which are scanned. And if you just here, it's just the number of packets we received. I think it's per hour. You probably see that there is a big peak. I think it's very evident here. And then, well, you can think, okay, there is probably a new service which is now being, let's say, vulnerable, and people look for this service or this software. Which is very interesting to look. Actually, it's the date it happens. And if you look at the dates, you understand that it's related to some geopolitical event. It was related to the US election. So again, this attack, then we look a bit what was targeted. I mean, here we don't see the attack. We just see what the attacker are looking for. Okay, then we don't know if they really attack or not. But here, basically, what was looking for was related to the e-voting system of the US, of the ESA. Not the e-voting machine, but the server that is used for collecting the votes. So, as you can see, security of IoT can be the IoT devices itself, as I showed you in the previous example, with the smart plug in general, the Mirai botnet, or can be also the whole systems that is around the IoT device. So when we talk about IoT security, of course, we have to consider everything. And here I try just to really sketch up what it could be a IoT system. Okay, you have different devices, you have a gateway, you have a lot of different protocols that can be in use. You have the cloud services, of course, and most of the time you want to use IoT service, even if the IoT is just a few meters from you, it goes first to the cloud and then back to the cloud to your device. Most of the time you don't have direct control, of course, because providers want also to keep the control on their services, but it means that you don't have direct control on your devices. And it basically leads to a lot of potential place for the attacker to be. So this is a very marvelous playground for an attacker, IoT, as you can see here. And yes, there are multiple devices, multiple protocols, and so on. Okay, it was just to give you some statement and some assertion we do, some real measurement we have done so far. So then the question is, should we address the IoT security as the same as an IT security? I mean, probably you understand with the question that the answer is no. Of course, we have a lot of commonalities between the two. In both cases, we have different hardware, software, operating system, services, users, we have cloud, and so on. There are, let's say, distributed or decentralized systems, and of course, all this will increase the attack surface. Maybe we can think that for IoT, it's another order of magnitude, but basically, it's very similar. The same is that what's the problem of security in general is that the user prefers the usability and rather than the security, because they want first to have something that works rather than something which is secure, because they are not really well aware of what could be the impact on the security issues. And of course, for the company, it's better to, if you think about IoT, to be the first one, to be the first one to sell the next very famous IoT device and application, killing application, rather than to be the last with security. Better to be the first without security rather than the last without security, unfortunately, just for economical reason. But let me show you how these differ on particular points. In particular, usability. Okay, we are all agree that even user and computer prefer usability, but no, just imagine IoT. Most of the time, the smart devices you have almost no interface with user. They are limited to some buttons. You have no keyboard, most of the time, no screen. So meaning that the user cannot really access to it or configure it, okay? At the same time, that's meaning that the user, even if he's aware of potentially some security problem, he has no way to really check and address those problems. He has to have a trust in all the people that are behind, let's say, the IoT device or IoT system that has been installed at its home or in, for example, in his company. So basically, it means that you should have a good trust in the manufacturer, but as many people are included, the vendors, developers, the provider, installer, and so on, okay? So just imagine that, yes, sometimes a lot of software, some integrator takes the software, stuff the hardware. For example, for heating system, automated heating system, as a home user, you will let the installer, installing the heating system, and probably will also configure the thing, but he has no, of course, maybe he may not have the knowledge to about the security that is necessary to secure it. So this is one of the big problems that you have. You have, of course, a lot of factors, and the usability is, of course, in that case, as it's you need this usability, and you have very few way to really control and configure. So if you do some parallel with IT security, of course, over the years, people were more aware of the security problem. And at the same time, they have been provided with tools that they can use as they can configure, even at the high level, like antivirus, firewall. So people today know that on the computer, they should have some security solution installed. In the same way, we have built, as a security expert, I've built a long and a very strong expertise in IT security. That is part of the assessment of security and any system. But of course, the problem I will show you after is that how we can translate this expertise, and now as we will have a system which will be more, diverse and in the different environment. So 3 challenges. I don't say these are whole because I just want to focus on here on some topics. The first problem is that you want to monitor the security. You want to do some security, you need to monitor your system. As I say, you will probably just buy some devices and will put in place. And most of these devices will probably use non-standard protocol, or proprietary protocol, of course. It might not be easy to know where these devices are. Most of the time, you may not even know that you have devices that are connected over internet. I was just mentioning the heating system before. It was a bit on purpose. We discovered in my university, or my previous university, that we have exposed the heating system to all over internet, but we were not aware of. It's just the installers. They install the heating system at the university, don't really care that this system can be connected, it can be remotely controlled, and then we discovered it afterwards. So yeah, first of course, you need to know what is accessible, you need to discover them, and it's not very easy, I will show you then. And of course, as I said already, configuration. What the user can do basically is he can play with the application. What I mean by application, he can play with the real purpose of the devices or the system, switching on light, opening doors, and so on. But as no, for example, cannot check what is the software installed on the IoT system. I don't say there is no IoT system that allows that, but most of the case, it's not the case. It's like that now. How to check that actually if it's secure or insecure? Of course, as I said before, there have been experts in let's say, threat assessment in general. You have many techniques. You can do some pen testing, you can do some phrasing, you can try to find vulnerabilities of our devices. We have databases that we can use, like Metasploit. We have, of course, a lot of tools that can be used. And modeling from university, but from academic, from industry as well. Including verification also. for example, verification of software and so on. All this could be used. There is no reason that we cannot use this kind of techniques for IoT security. The problem is that, as regular, this is still mainly manual process, and this is costly. And of course, you can do that if you have, if you have enough resources, if you have a big company and so on. But then, if you go for a smaller company, or even if you think about the home users, of course, they will not, for example, they will not hire a pen tester to check the IoT system at home. They cannot do that, right? So we need, of course, something more, as usual, something more automatic to avoid all this overhead that is induced by this problem. So what we are currently building is the SCUBA platform. So SCUBA is a platform for doing automatically IoT security assessment. So how this work? We have first we need to extract some knowledge on the target system. There are different things. I think the one which is very necessary is first to discover the different devices, and it's not always very clear how to. And then basically with knowledge extraction, which we correlate this information about the current IoT system with public databases like CAPEC and CV, which are databases regarding existing vulnerabilities and attack. And we try to have a graph of knowledge that represents our system, and that also represents our system with a potential, let's say, a point of risk or threats over this graph. From that, we will be able then to automatically dig into the graph and try to find attack path that an attacker could use. And if you find this path, basically that means that the system will be inherently insecure. Because of course you can have some vulnerability, but if you have some protections that avoid this vulnerability to be exploited, it's okay. But it means that you have to look globally, and that's why we construct all this knowledge, all this graph of knowledge. Okay, then of course we'll have some visualization, but this is not very important. So of course here we are relying a lot of machine learning, artificial intelligence in particular, to do the knowledge extraction. So here is what we want to have, because we are at this stage now, we are more on the knowledge extraction. We want to have this kind of graph, which is basically representative of the smart plug I showed you before. You will find the different services which are running, like you have SSH, DNS, you will know what is the software that is running with the version, and with, some information about the vulnerability which are associated to this. You will know also how the system will work, you can have version of the firmware and so on. So the goal is really to represent, here it's only for one device. Just imagine now you have multiple devices, you have to do the same with multiple devices interconnecting together. So you want to create that. And there are many problems. I will just try to show a few of them. So the first one is, when you want to do that, the assessment of a IoT device, the device may not be active. You may not be able to observe that he is using SSH or DNS. Okay, you can try to stimulate it, but it might not be active at the time you want to do the assessment. And you may not be able to observe it. Just remember, in IoT we have multiple domains. That it means that even if you want to do some discovery at the IP level, maybe then you have a gateway, a Z-Wave gateway or whatever, and then you have a device behind the gateway. And we will need to know what are these devices. But of course, you will all, if you look at the single level, you will also need a gateway, which of course is not enough if you want to do an in-depth analysis. And also communication are encrypted most of the time. And so the last issue is that public databases are most of the time incomplete, that cannot be updated, cannot be up to date with the last attack. So here we are also working in the issue 3 of automatically deriving, let's say, even if you don't have the knowledge of vulnerability, we try to find automatic, let's say, common properties between systems in order to automatically map vulnerability one to another. But let me focus now on the issue 1 and issue 2, which is the problem of that devices may not be directly accessible, that communication may not be observable. So one, let's say, regular architecture, there are several ones which is used for IoT. You have usually a local gateway that will okay, connect with your IoT device with different protocol. Can be, as I said before, Z-Wave, Bluetooth, and so on. And then you have your application service provider. And usually you interconnect with this, not directly with your, or you can do both, but you also interconnect with the cloud application. So if you do, as I said before, if you do simple technique, like you try to monitor the traffic and you try to extract some knowledge, it might not be complete because it might be encrypted and the devices might not be active. So what we are doing for that, actually you should directly try to trigger some action by sending some stimuli to the application in the cloud. So it's what we are currently doing. And then, of course, it will be having impact. And we are trying, because this is ongoing work, what we are doing now is to model what you can see here. We try to model the traffic that we see here. And in the sense that we should be able to automatically infer what happens on the other system, on the end system of the IoT deployment. Because basically most of the time you can monitor easily here. Here it's more difficult because you need multiple protocols. It's not infeasible. But in our case, we particularly target for, let's say, home user installation like home automation. That means we will not say to the user, you will put a big boxes with all protocol in your home. So what we propose most of the time is a service that is outsourced, meaning that we would like to do the monitoring from here or from here because we can control both. So it's one way to do. So if you look regarding what we have done so far on the analysis, let me just try to summarize a bit some view I have for the assessment of IoT system. So of course, it will be the best to have some, let's say standard or at least common practice or protocols to be used by all IoT devices and systems in order to monitor and maybe configure it. That will be the best. If you have that, and if you can force or recommend some security mechanisms to be implemented, we have security by design. Unfortunately, even today, in the last products we tried, and for big companies in IoT, we saw that some of them, I will not say many of them because I don't have too many manufacturers, still not using encrypted communications. So you are still be able to leak a lot of information regarding the user activity just by looking in communication and to the internet. I mean, to the cloud. So this is a problem. Of course, we should first or recommend, and then the question is which ones, because each time you want to implement some security mechanism, it's a overhead. You have first to assess what are the potential attacks, potential threats, and then to put in place security mechanism. As I said, there are probably some of them that should be by default be implemented. Like, of course, you should maybe need to use authentication and things like that. But of course, you cannot expect that everybody or every, let's say, company that would like to provide some service for IoT or build devices are experts in cybersecurity. That's the problem. And you will not refrain innovation. You will avoid that only big players with all the knowledge and expertise in security will be able to continue to provide new services and devices to the market. So basically, you should assume that devices will not be secure by design totally. We should force some of this, but not totally. So if you cannot force everything to be implemented, we have what we propose actually, just to summarize, is offering. We try to offload the security to something else. In our case, will be a kind of application in the cloud that will do the assessment. So assessment, yes, because the first thing is to know the risk and threat before trying to apply countermeasure. Currently, we are not at the stage of countermeasure. We are not only at the stage of assessment. So we propose to use active assessment. It works. But it has a lot of drawback because you are never sure that, for example, you identify all devices. Just identifying all devices by unique name or software by unique name is a real nightmare. It works, but in my opinion, if you want to go further today, we should go for more collaborative mechanism. In the sense that we should not do any active assessment. Okay, assume that, okay, we we assume that system will not be secure by design or by default, and people should assume that from when they, I don't know, when they will bring a new device to the market. They should say, okay, I'm not expert in security, my device may have some potential vulnerabilities. I should clearly mention it. And I should, in that case, basically clearly state what are the vulnerabilities, if I know, or at least state what is my device composed for. This is something that today you cannot know easily. If you don't do active assessment, you will not know what are the software that I use on your RDT device. You cannot, you cannot log in and try to know what are the software. So we should have, in addition to security by design when we can, to have some protocols, and we can use protocols that existing for announcing capabilities that either announcing capabilities will announce vulnerabilities or at least announce exactly what is the composition of the device, because then we can do all the assessment from that and it will be more precise. So if you cannot be secure, just say you cannot be, but be honest. That would be the best that we can do for security, and of course then you can think that we should have some trust management to who you announce and so on. So thank you. It was my talks for some conclusion and with some view about the IoT security. I just want to acknowledge some colleagues and project here. Thank you.
Do you have any questions? Yeah, please. Yeah. Using the mic.
Yeah, thank you very much for your interesting speech. You as far as I understand, you suggested to define a selection of security policies. At least it could be interpreted this way. And my question is, let's assume we had defined a set of 100 security policies and be able to select them, among them a suitable one. How can a device, an IoT device, in a trusted fashion, confirm it has implemented one of them?
Yeah, yeah. Basically, what I proposed in the last slide, either you are able to kind of certify or ensure that you have implemented this security policy, or either you just announce what is your kind of composition in terms of software and so on, and that you let then what we have now, the security assessment part, do the job for you. Oh, you can be sure. I mean, this is, as I said, there are many techniques from regular security, from state-of-the-art in IT security that can be reused. I mean, you can do some, even in our case, academic, we like a formal verification somewhere. It can work well, but it's costly. And you need to, yeah, it's possible. I think most of the time you could be able to use regular technique, but it will be costly, and otherwise you just delegate and say, I'm composed of that and that and that, but I don't know if I'm vulnerable or not. Is that answer?
So you're saying it's possible, first of all. Can you confirm, yes or no?
To ensure that a secure policy is in place?
Yeah?
Yeah, to a certain level, yes, you can confirm. If you're able to model your system perfectly, yes. Then you have models that can confirm that some authorization, control flag, control flow, and so on.
Then we have a solution. So what's the problem? We only have to certify this level, and
that's the problem. So the problem is how you certify. That I mean, the problem is how you model. The problem is complexity of system. In particular, when you integrate different software from different places. If you control, if you control from the events, from the hardware to the software, if you control all the chain, maybe you will be able to have a perfect model of your system, and maybe you can certify. But this problem is that you have most of the time no control from.
Do you see anybody who would be able to certify security, such a thing?
That's a very hard question. I know there are discussions how to have. Of course, there is some common criteria that you can use. I mean, CC common criteria well used now for security. But most of the time, they do not certify your secure. They just certify you verify certain properties that are good for security, let's say, but does not give you.
So what we need is somebody who satisfies a certain security level. I don't care how many, and some signaling that in a trusted way confirms that the device is meeting that certification. Then we're done.
For that, yes.
Maybe
I think it's really dependent on the level of the properties.
Do you have any questions? So let them talk like offline. Okay.
Okay.
So any other questions? If not, let's move to the next one. Thank you.
Thank you.